in this problem number 89, we're going to be adding these two fractions, and they have different denominators. So we know what to do here. We're going to start by rewriting the fractions, but with factored denominators. So let's do that now. So we're going to have, let's see if I can get this to work, x plus 4y over, how about x and x? And for this 36, I'm thinking a 6 and a 6 to give me that 12. But we got y's there, so include the y. 6y, 6y, plus x minus 6y. And this is going to be an x and an x. Now, in this first term, I've got the two factors in the denominator being the same. So I'm going to write these as x plus 6y squared. So I'll have x plus 4y over x plus 6y squared plus x minus 6y over x plus 6y, x plus 4y. Now here's our LCD. We got the denominators factored. We can just write this off. So we're going to have x plus 6y, it appears to the second power here. X plus 6y is just to the first power here. So we use the factor with the higher power. So let's use x plus 6y squared. And now there's also this x plus 4y. So we want to include that one too. So we'll get x plus 4y. And there's our LCD. So now let's draw a big fraction bar. I'll do it up here at the top. And we'll write LCD down here. And let's go back and look at these numerators now. So let's look at this one. Any adjustment necessary, we ask ourselves. Plus, now what about this x minus 6y up here? So x minus 6y, let's go back to this one. Compare the original denominator to the new one. Now this has the x plus 4y. It's also got an x plus 6y, but the new one has two of them. This has only one, so we're going to have to multiply this by x plus 6y. So back up here at the top, let's multiply by the conjugate, as it turns out, x plus 6y. So let's make these multiplications. We're going to have x squared plus, now this outer product and inner product, 4xy and 4xy gives us 8xy, and then a plus 16y squared, plus, now these are conjugates, so we can just square the first, getting x squared, put a minus sign and square the second, 36y squared, or just multiply it out if you like, all over the LCD. And now let's combine any common terms. Here's an x squared and another x squared, so we'll have two of those x squareds. There's an 8xy and no other xy's, so we're having a plus 8xy. And then we've got, what have we got here? We've got 16y squared, and we're going to subtract 36 of them. So that's going to be a minus 20y squared over the LCD. Now, I noticed this is that every term up here has a 2 in it. Let's factor the 2 out. So we'll get 2 times x squared plus 4xy minus 10y squared over, now, I'm thinking we're going to be done here. This is not going to factor. At least I don't see it. A 10 and a 1, I can't get a 4. 5 and a 2, I can't get a 4. So I think this is not going to factor. So let's just go ahead and write our LCD. So the LCD here is, now we've got it over here, right? We've got it back over here in our circle here. So we're going to have x plus 6y squared times x plus 4y, and I think that's the best we're going to be able to do. So just keep in mind what it says now is what we're doing. We're taking this set of computing instructions, making it much more convenient for the user by rewriting it this way.